speaker is Dhanya Krishnan. I met Dhanya in Women Academy, Developer Academy, Google Developer Academy, and she is a senior engineer manager at Choreograph. She is so interested in very scale and large systems. This is why she did her master thesis in the scale distributed systems, and she published her thesis afterwards in the worldwide web consortium where the Google search engine paper was published. Actually, she is trying now currently to work with. She has hands-on experience with Hadoop, with big data, with distributed systems, and with enabling a lot of customers doing their marketing campaigns using those, like using microservices and such technologies. Now about her hobbies, she likes hiking and gardening. Let me welcome Dhanya again. Please, the mic is yours.
Thanks a lot, Ruba, for the warm welcome. That was a lot of information. Yeah, I'm really glad to be part of the event, and thanks a lot for all the work you guys are doing as organizers for the Women Techmakers. And hello, everyone. My name is Dhanya. So maybe let's directly jump to our presentation. I hope you guys can see me. See the slides, right?
Yes, we can see.
Yes, so today our talk is about scalable distributed systems, a general overview of large-scale systems. I would like to introduce you to the core principles that we would be using while, oh, sorry, I'm not able to go to the next slide. Oh, I don't know what happened. Just a second.
No worries, sometimes resharing helps.
Yeah, I would try that. Now?
Yeah.
Yes,
fine.
It works. Oh, sorry for the mess. Okay, all right. So today's agenda is actually to go through some of the general concepts that we use with large-scale systems, how to build up large-scale systems, just so that you understand all the core concepts that we are using when we say scalable systems. Google search. So Google search is one of the very frequently used large-scale system that everyone knows about. Google search handles around 3.5 billion requests per day. So everyone knows to use it. Just enter something in the Google search, click and boom, I get the reply. Just think about the scenario if it takes maybe 10 minutes or 5 minutes for me to get some reply from Google search. So I think as a user, maybe I would never use Google search again because my time matters, right? As a user, I don't really want to wait long for an application to actually give me some response. So here we come to the term of performance. Performance means the speed of a request response, how fast your system can serve or how fast your system can give responses. So let's say you're building up an application. Maybe you want to build up an application like Instagram or Facebook, and you want to open it for the general public. So for the users to start using it. Okay, your application is starting to get attention. You're getting more and more users. You're happy because your user base is increasing. After some time, you notice that you're getting maybe around 1 million requests per minute. So you notice that your system is still performing, but little bit slow. Your system is getting slower, but then you're gaining more and more popularity. Your load increases, so your system either starts to get more slower or your system fails. So what does it mean here? What is happening? Here we come to the term of scalability. Scalability is actually performance under load. So how does your system perform when you have a lot of traffic or when you have more load? Scalable systems. Generally, when you say about scalability, it is the ability of your system to handle large amount of work by adding more resources. So by adding more resources, what does it mean to add resources to your system? That is, if you're building up a system, how can you actually scale your system? There are basically two approaches to scaling, that is scaling up and scaling out. Scaling up, so you have hosted your system, you have a server, you are seeing that load is increasing. So you want to scale up your system, for example, as one of the strategies. Scaling up means that you are essentially increasing the capacity of your server. For example, at first you had a small server with 2 CPUs, 1 gigabyte RAM, and 20 GB disk. But then you decide to scale your system up to handle the traffic, handle the load. So you are adding a bigger server. So you are adding more resources to your server. That's one of the approaches for scaling. Another one is scaling out. That is, instead of making your server bigger, you're adding one more server. So you're adding more machines. So this is a commercial or a cheaper approach of scaling your systems. Okay, a lot of technical jargons, but how do I actually handle traffic when I'm having an application and I have opened it up to the users? So when we say about traffic, or when we say about building up a system and hosting it, this is the general architecture that comes to your mind, a client and a server. So like a client server architecture. So you have a client sending a request to a server. Maybe there is further things in the backend. So maybe the server is sending your request to your business logic. So your API server, which handles the logic, which probably calls the database or does whatever processing that's behind and then gives the reply back to the client. So that's like the general functionalities that's happening. Now, let's assume one web server can handle 100 requests per second. So we reached here because we noticed your application is getting more and more popularity, more and more requests. So it's like there are a lot of clients who are trying to contact your web server, which means your web server is now the single point of failure because it cannot handle the load that is coming up. So what do we do at this point when you notice your web server cannot handle the load? Here we come to the concept of replication, which is one of the very frequently used concepts in large-scale systems. So instead of having a single instance of a web server, you can choose to have multiple instances. So if obviously, like how you see, if one web server can handle 100 requests per second, then adding up or replicating the web server. So if you have 3 web servers, you can handle 300 requests per second. So you are trying to handle more and more traffic that's coming. So you replicated the web servers, which means you can obviously increase the number of requests that you can handle per second. Okay, we have a lot of clients. We have decided to improve the number of web servers by using replication. But now, how can the clients identify which web server to contact? Because now there are many instances of the web servers. Here we come to another important concept, that's load balancing. So like how the term suggests, the English term, load balancer is actually a component that balances the load. So distributes the load to the different web servers. So different clients can send the request, the load balancer picks it and distributes the load evenly to the web servers. Now, when I say distribute the load, how does the load balancer do this? So there are a lot of different strategies that can be used for just simple understanding of yours. You can think about round robin, which basically means the first request that load balancer gets, it sends to the first web server, the second one to the next web server, and so on. So it goes like a cycle. So it's like one of the simplest algorithms you could think about. So a general architecture, once again, coming back to the point, you have your application, you have decided to replicate your servers, load balancing is handling the request to the web servers, but then there is some logic going on after the web server. Maybe you have more application service, which is doing a business logic, contacting the database to read or write to the database and so on. But if you look, you have handled the traffic now by replicating servers, but now your database is acting as a single point of failure because when you have more web servers and when you have decided to handle more requests, the database is just a single one. So all the requests from all these 3 web servers would now be coming to the database. So what can we do here? How can we scale out a database? So I'm just picking one example of scaling out the database. As we already saw, we could also scale up or scale out. So let's see how we can scale out. To most frequently used patterns, scalability patterns, is replication and partitioning. So replication, maybe we already saw about our web server. So we just replicated, as in we created more instances of the web server. Similar to that, replication basically means creating an exact copy. So let's assume you have a table which stores the information of your users. For example, the users whose name starts, so like user A to user Z, by that I mean consider a table where you have all the users, and A or Z represents the first letter of your the name of your user. So replication basically means you have now replicated or you have created another instance of your user database. So that's one of the strategies where you can, how you can scale. Another one is by using partitioning. So what is meant by partitioning? As you probably see in the figure, all I have done is splitted up the data, like I literally horizontally splitted up the data if you are actually considering a database. So now I have chosen to keep all the users whose name is from A to F in the first database instance, and then remaining in the next two, like how you see in the figure. So this is another strategy of scaling your database. But if you logically think, you can actually find a problem here. So, you know, there are, even among us, there are a lot of people whose name starts with A, B, C, D, but not many whose name starts with X, Y, Z. So as you see, you can already see that the first instance probably now acts as a single point of failure, because more of the request will go to the first instance, obviously, because there will be a lot of users whose name actually starts with those letters and not many with the last few letters in the alphabets. So this is probably not a best example to show how I would partition the data or how you should partition your data, but just for you to understand what partitioning means, this could be taken as a as a tip or like an example to understand. So in real time, how we do partitioning is we want to uniformly distribute the load. So we use a partitioning strategy such that almost equal load goes to each of these instances. So in a large scale system, the whole point why you decided to scale was to distribute the load. So you don't want to choose any strategy that would again focus all your load into one system, one instance. So you have to choose your partitioning strategy a bit more wisely. Okay, again, coming back to the point, not too many technical stuffs. How can I actually handle the requests when I'm building up a system? So we began from here. We had a client and a web server. When you have hosted your application, you start getting few users initially, you were all happy, but then you start having more requests, or your user base started increasing, but your web server actually became a single point of your failure. So you chose to replicate the web server so that, you know, so many requests could be handled. Based on the number of requests that you get, you can choose how many replicas you want to have, or how much is your throughput you want to handle. Throughput basically means the number of requests you can serve per second. So here we also came to the concept of load balancing. So we have put a load balancer that would distribute the traffic accordingly to your web servers, so that, you know, the high traffic can be handled. So eventually we found out that your database now acts as a single point of failure. So database is getting more requests. You would be using some metrics to understand where exactly is the problem of your system when you build the system. When you see, okay, database is having some problem now, then you choose to progressively improve by either choosing replica, or maybe you could also use partition, or a combination of both here based on what your use case is. And once again, a load balancer comes to play here because you also want to distribute your load accordingly when you have multiple replicas, or when you even have partitions. So this is generally how you can progressively build up your system. So today we are focusing on progress, not perfection, right? So initially, when you start with your system, you would start with smaller number of components, because you never know, maybe you could also consider the other scenario. You're probably not having that many users and not that much traffic. So you don't want to overburden yourself by adding all the components at first and unnecessarily increasing the complexity of your system. So in order to achieve this, you would be using a lot of metrics. So when you build up your system, you would actually use metrics like the latency, or as in how much delay is there when your request is being served, or throughput, how many requests can you handle per second. So these kind of things you would be noticing, as in you would be monitoring. You might also be doing monitoring of the queries to your database so that you can understand how the traffic is there, or what is the component that will act as my single point of failure. So you want to iteratively, or you want to progressively build up the system instead of putting all the components at first and increasing all the complexity. But you should also know what the components be. So you should actually be ready to integrate the necessary components into a large scale system when you are actually building up a system, expecting that you want your system to scale. So even though you have seen all these components, even though it seems there are a lot of components involved, it's not that tough to do, because you have all these things like the load balancer, the web server, the database. You're not creating all this from scratch, right? These are the things that already exist. Your application logic is the one that you would focus more on building. What you need to know more is to know how to integrate these components together so that your system can be scalable, or your system can be capable of handling higher load, or perform under load, which is exactly what the scalable systems are supposed to do. So that was like the quickest I could talk about a large scale system remaining in the overview. As a recap, we have seen what scalable systems are. So any system that would be able to perform under load without breaking. So that's what's called as a scalable system. And in order to make your system scalable, you can use different strategies. And two of them would be scaling up or scaling out. Scaling up meaning that you are creating a larger server. That is, you are adding more resources to your server. But scaling out means that you are adding more number of servers so that your load can be parallelly handled. And replication. So this is a concept of scaling out itself, like you are creating more copy of your instances. And then obviously, when you have a lot of copies, you need to know which exact instance should be able to handle your load. So that's why you go to this concept of load balancing, or a load balancer, which helps in distributing your traffic. So these are like the general concepts or the general terms you come across when you talk about large scale systems. Yes. So if you're interested to know more about large scale systems, I did not want to overburden you with all the references or all the links I could put, but Designing Data Intensive Applications by Martin Kleppmann is one of the best data intensive designing book I have ever read. So I would definitely refer you to that. And also, if you're interested to know about real life architecture, for example, what is the components, or how is the scalable system like Instagram or Facebook or even Google search is being built, you can refer to highscalability.com. You will get a lot of information on real life architectures there, so that it will help you to understand how to design your own systems. Yes, I think that was short information. Thanks a lot for listening. Thanks a lot for being there. And if you have questions, just feel free to share.
Thank you, Dhanya, for all the interesting information about the scalability systems. I think there is now no questions there. If you have any questions, as mentioned, please drop it in the chat or send it to Dhanya. Please don't hesitate to contact her. Now I will hand over for our next speaker, actually, introduction.